In this video now we have orange. These are 20 distinct oranges kept somewhere in a basket. In this collection of 20 oranges, 4 oranges are rotten. Now if we randomly pick up 3 oranges from this collection without noticing good or rotten orange, what is the probability that this group of 3 oranges will include 1 rotten orange? So here formally the question is, if 4 out of 20 oranges kept somewhere in a basket are rotten, and if we pick up 3 oranges randomly from the basket, what is the probability that we will include 1 rotten orange in the group of 3 oranges we pick up? Let's try to find the solution. Here from this collection of 20 oranges, if we want to pick up group of 3 oranges randomly, we can do that in 20C3 ways. This is the count of mutually exclusive, equally likely, exhaustive cases belong to the sample space S of this random experiment. Let's assume A is the event in which 1 orange will appear rotten in the group of 3 oranges we pick up. What will be the count of favorable cases belong to event A here? Among these 20 oranges, 16 oranges are good, 4 oranges are rotten. In any favorable case, when we pick up 3 oranges randomly, we actually pick 2 good oranges from 16 good oranges. We can do that in 16C2 ways. For every pair of good oranges we pick up, 1 rotten orange can be picked up from the 4 rotten oranges here in 4C1 ways. This is how a group of 3 oranges we pick up, including 1 rotten orange in a favorable case. This is the count of favorable cases belong to the event A. We can calculate the probability now. Count in event A is this. Count in whole sample space is this. So the probability of getting 1 rotten orange in the group of 3 oranges we pick up will be this fraction, 8/19. This is the answer to this question. We have another sequential question here. Second question. What is the probability that at least one of the rotten oranges will be included in the group of 3 oranges we pick up from these 20 oranges? In solution of question 1, we assumed A as the event to include 1 rotten orange. Now for question 2, let's assume E is the event to include at least 1 rotten orange in the group of 3 oranges we pick up. That means in favorable cases for this event, we can randomly pick a group of 3 oranges which can have 1 rotten orange or 2 rotten oranges or 3 rotten oranges. So we can select oranges this way to form this group of 3 oranges containing only 1 rotten orange. Let's consider selection of these type of groups as an individual event U1. How many favorable cases possible for this event? 2 good oranges we are selecting from 16 good oranges here. We can do that in 16C2 ways. For every pair of good oranges we select 1 rotten orange, we can select from 4 rotten oranges in 4C1 ways. This is the count of favorable cases belong to the event U1. We can select 1 good orange and 2 rotten oranges to form this group containing 2 rotten oranges. If we consider this type of selections as event E2, 1 good orange we can select in 16C1 ways, 2 rotten oranges we can select in 4C2 ways. This is the count of favorable cases belong to the event E2. We can select all 3 rotten oranges to form this group if E3 is the event representing this type of selections. We are selecting 0 good orange and 3 rotten oranges from the 4 rotten oranges. This is the count of favorable cases belong to event E3. So if we calculate probability of event E1 is 8 by 19. Probability of event E2 we can get 8 by 95. Probability of event E3 is 1 by 285. Here E1, E2, E3, these are mutually exclusive events. We can notice event E to include at least one rotten orange is actually the union of these three events. If we can remember the third axiom from the axioms of probability, we can apply it for more than two mutually exclusive events also. That is, using this axiom, we can get here probability of event E equals to sum of these respective probabilities of these events, which can give us the probability of including at least one rotten orange in the group of three oranges we select as 29 by 57. This is the answer to the second question. Wait, we have the third question following here. What is the probability that none of the rotten oranges will be included in the group of three oranges we pick from these 20 oranges? Just like this. Let's consider for this third question, E prime is the event in which no rotten orange is included in the group of three oranges we pick. Notice here that E prime is actually the complement event of the event E this side, consisting of the cases in which one or more rotten oranges are included in the group of three oranges we pick. So we can write here probability of event E prime equals to 1 minus probability of event E, that is 1 minus this value from here, which equals to 28 by 57, which is the answer to the third question. Now we can calculate this probability in another way. You can notice in a case of picking three oranges containing no rotten orange, we are actually selecting 3 good oranges from 16 good oranges only, like this, which we can do in 16C3 ways. This is the count of favorable cases for the event E prime here. So in our usual approach using the definition of probability, probability of event E prime will be this ratio, which equals to 28 by 57. This is the answer to the third question. Same to the answer we got here previously.